Hello, today we continue with our geometry unit. We are studying quadrilaterals, and particularly we've been looking at two quadrilaterals in particular. We've been looking at parallelograms and a special type of parallelogram, a rhombus. Remember, the difference between parallelograms and specifically rhombuses is rhombuses have to have 4 equal side lengths. So in the last video, we talked about the angle properties of these two quadrilaterals. We learned 3 things. First, that all the interior angles all together must add up to 360. This is true of any quadrilateral. Now, specifically about parallelograms, we learned that the opposite angles, the angles across the shape from one another, have to be equal. So if one angle is 40, the other angle must be 40, and so on and so forth. We also learned that the adjacent angles, or side-by-side angles, are supplementary. So if I see the 2 angles on the bottom, the 2 angles on the side, the 2 angles on the top, those have to add up to 180 degrees. Now we're going to use these theorems, these laws that we've learned, to try to find missing angles in a parallelogram or in a rhombus. Let's get started. So we know that opposite angles of a parallelogram are equal. I want you to look at the parallelogram at the top of the screen. You'll see angle B and angle D, both colored in blue. They have to have equal measurements. And angle A and angle C also have to have equal measurements. Right now, we're not so worried about exactly what the number of degrees are. We just know that they have to be equal. On the bottom, we can see the second part that we learned. The side-by-side angles have to add up to 180. So let's look at all those side-by-side pairs. A and D, 180, add up to 180. Angle D and angle C are also side-by-side, and they add up to 180. Angle C and angle B are side-by-side and add up to 180. And finally, angle A and angle B across the top have a sum of 180. Okay, so it works all the way around a parallelogram. It doesn't matter which point you begin with. So now let's do this together. We need to find the measure of y. Let's think about which of our 3 theorems is going to help us. The sum of all interior angles? No, we only know one angle, so we can't really add up all 4. Okay, what about opposite angles? Is y opposite the angle that measures 120? Yes, it is. So the adjacent angles isn't going to help us because those angles aren't side by side. So let's use our opposite angles theorem. Remember that opposite angles in a parallelogram are, you got it, equal. So angle y must measure 120 degrees because they're equal. Next, we need to find the measure of angle z. Let's think about which of our 3 theorems is going to help us. The sum of all interior angles? No, because we don't know 3 of the 4 angles in the quadrilateral, so that won't help us. What about our second option? We have the opposite angles. Well, is z opposite the angle we know? No, they're side by side, so we're going to use our adjacent angle theorem. Remember that side by side angles have to add up to 180. So to find the mystery z, I'm going to flip that math problem around. Instead of using addition, I'll use subtraction. Remember when we solve mathematical mysteries, we use algebra and opposite operations. So I'm going to start with my total, 180, and I will subtract 115 degrees, okay? And my final result, my difference, is going to be the measure of angle z. So let's do that. Let's subtract 180 minus 115. I'm going to do it for you guys using mental math techniques. So first we're going to subtract the 100. 180 minus 100, just 80. Now we're going to subtract the 15. 80 minus 15. Now you can break this down to a next step if you need to. 80 minus 10 gives you 70. Right? And now 70 minus 5 gives you 65. Or if you can do 80 minus 15 in your head, 80 minus 15 gives you 65. So the measure of angle z must be 65. That angle z, 65, plus the angle we already knew, 115, gives us our magical supplementary sum, 180. So now we found these missing angles together. The next step is for you to try it on your own. You're going to do an assignment on your own and turn it in. Let me show you what that assignment looks like. okay? We're looking at Wednesday's quadrilateral practice. You can actually download and print this worksheet, or you can do the work in your own math textbook if you have that at home. So in this practice, the figures are not drawn to scale. That means you shouldn't be measuring it with your protractor. You need to use algebra and mental math or operations to figure out what these mystery angles and lengths actually are. So using everything we know about a parallelogram, we're looking in the first question for what the length of BC is. So it's this side that's right across from the side AD. Hint, you can use the length of AD to find the length of BC. In problem B, you have another side length question. Next, in problem C, we need to find the measure of angle ABC, or angle B for short. Okay, so in this case, we want to use our adjacent angles theorem, those side-by-side angles. Are the measures of angle ABC and ADC equal? Is angle B equal to angle D? Well, you tell me using the opposite angles theorem. So you're going to continue on like this. In the second problem, you're asked to find unknown angle measures. And I want to remind you that this little square that we see down here, this indicates a right angle. Remember that all right angles are equal to 90 degrees, okay? So we're going to be using that information and more to find out the measure of angle D, okay? Next, in this problem number 2, you need to find A, B, and C, and D. So there's actually 2 answers for each problem. In number 3, you are given one angle, and you need to decide if SPQ, boop, 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 is also 114 degrees, and explain your answer. In that case, you want to tell me which theorem you used. So write a little sentence next to that. It's not just yes or no, it's yes because or no because. What is the measure of RSP? Now, once again, you're going to actually do the work and solve and find out that answer. Remember, if you're using the side-by-side or the opposite angles, okay? And in number 4, you have the last little bit where you need to find 2 missing angles. This time you're finding the missing opposite angle across that rhombus, and you're finding the missing side-by-side angle. So use those 2 theorems. Now, if you need a repetition of what do I do with the side-by-side and what do I do with the opposite, just scroll on back in this video and you can find your answer there. Any other questions, let me know. Thanks again for listening. This was practicing the angle properties of parallelograms and rhombuses, which are 2 very special quadrilaterals.